Okay, so last week we learned about the trigonometric functions. This week we're going to cover special triangles. Special triangles. Here's a quick review of what we learned last time. So last time we learned that when you have a right triangle A, B, and C, and with angle theta, you would establish these 6 trig functions. So sine, cosine, and tangent. And we also learned that we also learned the reciprocals of these functions. So cosecant, secant, and cotangent. And note that, just gonna quote it here. Note that cosecant equals 1 over sine. And we also learn about the inverse, which are okay, let's write it here. Sine to the -1, cosine to the -1, and tangent to the -1. Okay, technically we shouldn't do that. Okay. And what this means, contrary to popular belief, when y equals sine theta, theta is equal to sine, the inverse sine of y. This is what this notation, let's emphasize it. This is what this notation means. Never mess these two up. Okay, never mess up. Okay, so this week we're going to be learning specific cases of the sine, cosine, and tangent. So basically, special values of these functions when you have a particular type of triangle, aka special triangles. Okay, so here we have our ABC triangle again. And when this triangle has angles 90, 30, 60 with the sides A, B, and C, the trig functions actually give you a exact value. Well, okay, let's show you what I mean. Okay, well, what are the side lengths of this? Well, let's first start with a equilateral triangle with sides 2 on all sides. And we want to find out what this side. Okay, oh, actually, we don't need this. We can just, we assume that, so we assume that the side length of each side is 2. So therefore, cutting this in half, this side length is equal to 1, because this is half of 2. Yeah, okay, cool. So now we know 2 sides of this triangle, and we can use the Pythagorean Theorem to find out what the side length of this side is. What is this side? We'll call it h. So therefore, a squared plus b squared equals c squared. And and also note that in an equilateral triangle, the angles is always 6 degrees. It's all 60 degrees. Okay, so back to this. This is 2 squared plus h squared. Actually, no, this is 1 squared plus 2 squared. Okay, if you do a bunch of algebra, we're not going to go through it. H is equal to square root of 3. Actually, it's not that much. Yeah, no. yeah, it's not that much. Okay, but in the end, we get that h is root 3. So therefore, the triangle we have then is root 3, 1, and 2. Okay, now, and we also know the angles of it. Splitting this half also bisects the angle. So this is 60 and 30, that's 60. Okay, now we can use this to establish some trig identities. Okay, let's go. So we have sine. Okay, let's do sine of 60. Sine of 60 degrees. We have cosine of 60 degrees. And tangent of 60. And we'll see what we get, right? It's pretty simple. Okay, sine of 60 is opposite over adjacent, opposite over hypotenuse. We learned from last week's lesson, so this is going to be opposite over adjacent. So therefore, sine of 60 is root 3 over 2. Now, cosine of 60 is adjacent over hypotenuse. Let's do a different color. Adjacent hypotenuse. So that is in fact going to be equal to 1, exactly 1/2. Now we got tangent of 60, which is opposite over adjacent, which we get as root 3 over 1, which is just root 3. Okay, these are all the values of 60 degrees of all these function, I suppose. Now let's move on to sine of 30 degrees. And in fact, it's almost the same things, except some things are flipped around. And if you do the same type of thing we did over there, you get that sine is 1/2. Cosine is going to be this, and tangent is 1 over root 3. Rationalizing the denominator, you get that tangent of 30 is also equal to root 3 over 3. Okay, and these are all the special values you need to know for this triangle. This is, in fact, this is called the 30, 60, 90 triangle. Okay, now besides this triangle, we also have the 45, 45, 90 triangle. So, where the angles are, which is basically a square that has length 1 cut in half. And this side, once again, the 45 and 45. Okay. Once again, using the Pythagorean theorem, we can find out the length of this hypotenuse. So 1 squared plus 1 squared equals h squared. And if you do some manipulation, that becomes 2. So therefore, h is equal to square root 2. So this is going to be our triangle. Now we go ahead and find out sine 45, cosine of 45, and tangent of 45, and see what we get. Okay, so for sine of 45, we see that it's opposite over the hypotenuse, so it's going to be root 3, root 2 over 2. And for cosine, it's opposite, the adjacent over hypotenuse, which is also equal to root 2, root 2. Actually, how do we get root 2 over 2? Well, this is actually 1 over root 2. We rationalize it in the denominator. And same for this. This is 1 over root 2. Rationalizing the denominator, we get root 2 over 2. And for tangent of 45, we got 1 over 1, which is just 1. And we are done.